Hello, I'm Ron Smith, Principal Investigator on the 4S Silversword contract time and phase synchronization across multiple airborne platforms. With me today is Bill Ziegler, 4S Program Manager. Hello, Bill.
Hello, Ron. Let me take this opportunity to thank our sponsors at NavAir for providing this STP forum where we can present our time and phase technology, which utilizes our free space optical communication system to a customer-rich audience. Before we get into the technology, let me tell you a little bit about 4S Silversword. We are a native Hawaiian-owned 8A and hub zone company. We have several related Navy SBIR contracts. These are TALC, a free space optical communications technology, mobile phase array antenna, an optically enhanced phase-aligned RF UAV ensemble, time and phase, an optically enabled airborne phase array radar, and MABEL, a marine air boundary layer modeling technology. We currently have multiple patents covering core technologies. We are co-located with the University of Maryland, Baltimore County Technology Incubator.
Thanks, Bill. Let me add that the Navy chose 4S and our hybrid RF free space optical technology for a reason. Our solution synchronizes multiple platforms, operates in a UAS relevant environment, and meets the Group 3 UAS space, weight, power, and cooling requirements. These benefits have garnered support from several groups at NavAir for our technology. To you, Bill.
Let me also extend our thanks to the technical point of contact for this work, Mr. Anthony Stefko. Ron, please talk to how the Navy can use our time and phase technology.
Okay. In this illustration, we see that a mothership has released a swarm of downgliding RF nodes. These nodes use our optical phase alignment system to form a synchronized RF phase array waveform directing a pinpoint beam toward the target, shown off to the right. This capability will be useful, for example, to generate a radar pulse without disclosing the location of the mothership. We call our foundation technology Through the Air Link Optical Component, TALC. TALC uses directed optical beams with tailored signal modulation to measure pose angle in azimuth and elevation. The TALC system also measures distance between platforms with high accuracy. Using our precision optical measurements from TALC, 4S develops a three-dimensional map of the RF node locations in an ensemble. This 3D map is then used to calculate phase values that will produce a pinpoint-directed RF beam in a desired direction. Back to you, Bill. What is the current status of our work?
Thanks, Ron. We are currently progressing toward our Phase 2 milestones. Our main objectives are 1. Development of an advanced low size, weight, and power TALC featuring an all-solid-state optical scanner, and 2. Demonstration of a hybrid RF optical TALC ensemble where the nodes are carried on tethered balloons and the ensemble produces a directed RF wave. The 4S time and phase synchronization solution brings many important features and benefits to the Navy. Our system achieves time and phase synchronization among all of the mobile platforms, maintains a real-time coordinate database locating all platforms, provides a common time reference on all nodes, and enables transmission of a pinpoint RF beam to designated targets. Now, we should mention where this is all going. Several Navy organizations may have interest in this technology. PMA 265, the FA-18 group, is our current sponsor. The others listed on the chart are logical participants. Additionally, Lockheed Missiles and Fire Control has provided a letter of support for our mobile phase array antenna architecture. The level of Navy support and interest in our work has been very gratifying. Our technology offers substantial benefits to the Navy. Ron, can you also describe some of the commercial opportunities?
Yes. In a first example, TALC free space optical links enable formation of a satellite ensemble into a phased array antenna. The large aperture produces a highly directional RF beam focused on selected ground receivers. The bidirectional communication produced in this way adds a new dimension to satellite communications. A second commercial application is terrain mapping for large area surveys, where combining phased array antenna and side-looking airborne radar technology may produce high-resolution mapping in both range and forward travel.
Thanks, Ron. Now, this closing slide provides our contact information. We are always ready to hear from you, whether to provide more in-depth details about our work or to discuss other opportunities you may wish to explore. Thank you for your time and attention.